Okay, so this question here, just to save us some time, I've already input the functions into our calculator. So if they're the two functions, find the area bounded by fx and gx. So that means we're calculating this slither in between the two intercept points. So I'm just going to execute that. I'm going to draw it. And now I'm going to scroll up because my calculator, this model doesn't love it when it can't see everything. So this, from this point, is a really simple question. I'm going to G-solve, go across, integrate this bad boy. I'm going to do it between the two intersect points. So it even tells me the intersects. So if I really want, I can write them down, but, you know, whatever. So execute that one, then go up, press across to the other one, press execute. It tells you that this is the area. So all I have to do now is write this over here in my function. Now, the question is worth 4 marks. So because it's worth 4 marks, I would be saying that you need to state the intercepts. They are probably thinking that you're not going to be that good with your calculator and you're going to do some algebra for it, but sucks to be them because we know our algebra. So all I have to do is state that the area is equal to 0.29, we'll go to 4 decimal places, 87 units squared. Now, if you miss the unit squared, I'm guessing that'll be a deduction of half a mark. Okay, but that's it for that question. Not hard. Just need to know how to use your calculator. This question. The velocity of a particle is given by this. Determine the velocity of the particle after 2 seconds. So that means that we simply need to substitute in velocity when time is equal to 2. So that'll be e to the power of 2 over 2 minus 5 times 2 minus a half. So chuck that in your calculator. E to the power, or 2 times 2 is 4, divided by 2, minus 5 times 2 is 10, minus a half is just 0.5. Execute. So at 2 seconds, when the velocity is equal to 2, when time is equal to 2, the velocity is 16.7. If we're rounding to 2 decimal places, that's going to become 80, and this is meters per second. The acceleration of the particle after 2 seconds. So if we want to find the acceleration with respect to time, that means we need to derive our function with respect to t for e to the power of 2t over 2 minus 5t minus a half. When I take the derivative of this function, that 2 is going to come to the front, cancel out the other 2. So it'll just become e 2t minus 5. That function's going to go on the end. See ya. So at is equal to that. All I have to do now is substitute into that. So that's going to become e to the power of 4 minus 5 is the exact form. You probably could just leave it in exact, and that'll be meters per second squared. I'm going to punch it in the calculator. Because this is tech active, they probably do want you to get all of your answers to 2 decimal places at least, but whatever. Okay, so then that'll be 49.60 meters per second squared for the acceleration. Okay, next question. When is the acceleration positive? Menu. Graphy. Now, I am lazy, and you should be too. We know that the acceleration is going to be positive anywhere before or after where we find a stationary point. And so we can just look for that. So, delete this. See ya. Okay, and now I can start putting our acceleration function in there. So that's going to be shift e to the power of 4. oh no, sorry, e to the power of 2x minus 5. So I'm going to zoom auto. Let's see what it shows me. Woo. Okay, so you can see here it is actually the whole thing is increasing. Okay, so GSolve, not found, exit, draw, GSolve, min, not found. The whole thing is increasing. Okay.